We know that there are two poles in a magnet, a north pole and a south pole. So according to the law of magnetism, like poles repel and unlike poles attract, which means if we bring two like poles together, means both north pole or both south poles. So if we bring north and north or south and south together, we will experience a repulsion force. They will start repelling each other. But if we will bring two unlike poles together, means one north pole and one south pole, then they will attract each other. Therefore, like poles repel while unlike poles attract each other. We can verify the law of magnetism with the help of a simple activity. Take two bar magnets, suspend one of the magnet freely with the help of a thread. Now hold the other magnet in your hand. When the suspended magnet come to rest, you will see it will come to rest in north-south direction because a freely suspended magnet rests in north-south direction. Then bring the north pole of the magnet which you are holding in your hand towards the north pole of the suspended magnet. When both like poles will come closer to each other, you will see that the suspended magnet will start moving away from the magnet which you are holding in your hand, which means that the suspended magnet is repelling the other magnet because you have brought the north pole, that is the like pole, towards the north pole of the suspended magnet. So you will see that both the magnets will not touch each other. Now bring the south pole of the other magnet which you are holding in your hand towards the north pole of the suspended magnet. You will see, even without touching the magnet, that suspended magnet, the suspended magnet will come and attract with the magnet which you are holding in your hand, which means that both unlike poles, north and south pole, both the unlike poles are attracting each other. Thus we can see that like poles repel while unlike poles attract each other. Magnetic poles always exist in pair. We cannot separate the two poles of the magnet, which means that north and south pole of a magnet cannot be separated. Even if we break the magnet from the middle into two parts, again we will see that both the parts will be behaving like a magnet because they will still be a magnet. Each part will have the property to attract small pieces of iron. If we suspend each part freely, then we will see that the broken part also rests in north and south direction, which means that even after breaking the magnet from the middle, it is behaving as another magnet which are having two poles, north and south. If we again break these pieces, then still each small piece will have north and south pole, which means north and south pole exist simultaneously. We cannot separate the two poles of the magnet. We know that in a magnetic compass there is a needle which rests in north south direction. When you bring this magnetic compass near a bar magnet which is placed on a table, you will observe that the magnetic needle of the compass will start swinging, means it will not rest in north south direction now. It will start swinging in different direction. As we will change the position of magnetic compass at different points around the bar magnet which is placed on the table, if we change the position of the magnetic compass, then you will see that the needle will also change its position. So this means that there is some property, this space around the bar magnet has some property which is influencing the magnetic needle of the compass, due to which that needle is now not resting in north south direction, but it is swinging and moving in other direction than north south. So this space around the bar magnet in which magnetic compass gets influenced, that space is called its magnetic field. So whenever a magnet is placed at any place, any table or anywhere, then it creates a magnetic field around itself. In that magnetic field, if you bring a compass, magnetic compass, then you will see that the needle of that magnetic compass will not rest in north south direction. It will start swinging and it will rest in any other direction other than north south. To check the magnetic field around a magnet, place the magnet below a stiff paper. Now spread some iron fillings on that sheet of paper. Tap the sheet gently. You will see that all the iron fillings will arrange themselves in a definite pattern. That pattern will tell us the magnetic field of the magnet. The direction of the magnetic field will be from north pole of the magnet to its south pole. But the magnetic field is not uniform everywhere. We know that magnet can attract any iron piece which is placed in a particular region near the magnet, but it cannot attract every iron piece which is placed anywhere, which means that the magnetic field is strong near the magnet, but it becomes weak as we go away from the magnet. Therefore, the magnetic field is strong near the magnet, while at a distance from the magnet it becomes more and more weak. Earth's magnetic field. The Earth itself behaves like a magnet, which means that we consider that the whole Earth is itself a big magnet and it has magnetic field around it. In a limited space, the magnetic field of Earth is same everywhere. Means the magnetic field of the Earth is uniform throughout the space and it is in the direction from geographic south to north. Okay, so the geographic south and north, we have the directions north and south directions. So the magnetic field is from geographic south to geographic north. Now, if we have to recognize the Earth's magnetic field, we have to suspend a magnet freely. We know according to the property of magnet that a freely suspended magnet will rest in north-south direction, which means that the north pole of the suspended magnet will rest in the geographic north, that is the north direction of the earth, while south pole of the suspended magnet will rest in south geographic south direction of the earth. Okay, so which means that north and south pole of the magnet are resting in geographic north and geographic south of the earth respectively. Now we also know that north and south attract each other, means unlike poles attract each other. So if the suspended magnet north pole is resting in geographic north, this means that here near geographic north there must be earth's magnetic south pole. Why? Because if we have magnetic south pole here, then only the north pole of the suspended magnet will get attracted with the magnetic south pole of the earth and rest in this direction. So we have magnetic south pole of earth near geographic north. Okay, so the magnet which we are considering that there is a magnet in the earth, so the magnetic south pole of that magnet which is in the earth is towards geographic north. Similarly, in geographic south there must be magnetic north pole. Okay, so because of this magnetic north pole, the south pole of the suspended magnet will be attracted towards geographic south, we have magnetic north pole of the earth towards geographic south, which is attracting the south pole of the suspended magnet. So what we can conclude, that in earth we have two poles, geographic north and south and magnetic north and south. The geographic north is near the magnetic south pole of the earth, and geographic south is towards the magnetic north pole of the earth. That is why north and south poles of the suspended magnet rest in geographic north and geographic south direction respectively.